Chris, what time were you on the seabed?
Just coming into view. Good timing.
Oh, thank you very much.
Video, could you tell me which channel I should use to see the instant messaging?
It was SCS client 2 left, I think. Check it out.
Maybe SCS client right. 2 right. Let me try that. I don't seem to have that. Who should I ask for help with that?
Yeah, sorry, it's SCS client 1 left.
Thank you, video. Great. Well, good morning, everybody. Welcome to the seafloor. Today, we are on ROV dive 8, I believe. Somebody can correct me if I've got that completely wrong.
Got it, Chris.
I should read my own email, shouldn't I? The time is just gone 1500 UTC, 15:06. It's 10:06 here on the ship, 11:06 in Rhode Island. We have arrived for our shallowest dive of the cruise, we predict. We are on the bottom at a water depth of 2195 meters. We are just to the west of the very summit of Mount Dent, and we're going to be proceeding along a series of bumps just to the west of the summit. You can see that in the HiPAC navigation screen. We're going to be investigating a series of mounds. One of our prejudices for the day would be that is for the start of the dive, and this will be MCR077. Wow, that's fantastic. Can we look at that with Sirius? That looks like slumping in the sediment, like a scar that's just dropped down. I guess you guys need to settle up. Nav, I guess you guys need to settle up first, correct? Whoa, look at that. That's pretty. That's a big hole in the ground. Don't go down that alley, the ROV will get mugged. Thank you very much. And for everybody who's listening along, both aboard the ship and the ECC and anywhere else on the internet, while we're waiting for the excuse me. While we're waiting for the pilot and co-pilot to get everything settled out here, I would like to take the time to make a special mention for Cameron McIntyre, who's out here on the ship, and in particular for his daughter Charlotte. Today's her first birthday, so happy birthday to Charlotte, and a special thank you to Cameron that he's out here helping us with all the methane analyses and providing an invaluable support for everything we're doing, when I'm sure he would much rather be home for her birthday. So thank you very much, Cameron, as well.
Happy birthday, Charlotte.
Happy birthday, Charlotte.
And so, here we are on a little sedimented ridge. Our depth is 2198 meters. Our heading at this point is 014 degrees. It's just bringing the ROV in, so it's actually underneath Sirius. On Sirius, we can see all kinds of interesting things. There's a big depression that the vehicle's just coming up to. On the top of this ridge, we've seen scarring that looks like things are actually sliding downhill. There are burrows in that sediment, as well as the big depression. There was actually a little tunnel going into the side of it. But what's very obvious on the Sirius feed as well is that off to the left, there's actually bare rock down there, which is actually on the that's on the west side of the high that we're on right now. And navigator, just so you know, before we go anywhere, what we'd like to do is, looks like there are some nice bare rocks just downhill off to our left. So probably what we'd like to do is, rather than fly along the very top of the ridge, when you were heading, you were facing on around 0300 or 300 degrees. There we go. Let's go look at those rocks there.
Copy that. A little bit of current here.
How is that? So we're on a heading of 087 degrees. We're facing east into this steep wall. And there's a lot of sediment cover. There's a lot of sponges. And it's hard to see through all of that to actually see any rock type. Pilot, I think what we're going to have to try and do to actually see any rock is going to have to be to zoom in and try and find a patch of bare rock between some of these sponges. There's a slightly darker, less bluish grey to the colouring, so I think if you
Copy
Let's
that.
think.
I'm gonna back up just a little bit because the current's pushing me
very good.
towards a coral. Yeah, a little titanium mostly.
Okay,
What?
go ahead, Nav.
Could you maybe move your microphone a little bit closer around?
Okay, how's that, Nav?
Thank you. Much better. So, zoom in on one of these patches of rock. Watching, is that what you're wanting to do?
Yes, please, pilot.
Okay. I see a good one. Just at the top of my...
Chris, can we get lasers?
Can we go for
Say again, Mike.
slow zoom on video?
Can we get the...
Stop there. Now, Mike, does that look like some kind of radial fracturing? Is these pillow basalts? Is this wishful thinking? You see that one under the lasers there? It's almost like rotor blades or something that's...
Yeah, the one above looks slightly curved as well.
Yeah.
That would be our best guess, but
Yeah.
we'd like to see more.
Sure. Bare rock just below. There's some sponges. There we go. Keep going down. How about that? Can we get a zoom on that piece of black rock just there? Left laser would be the optimum. And then maybe just pan around, go left maybe? We could probably zoom a little wider, but not too much, just to cover more. There we go, that's good. And what we're looking for are curved surfaces. Pillow basalts are basically about 1 meter across, or up to 1 meter across. I think if you go top up left from the lasers there, just it's hard to tell what's an animal and what's actually volcanic rock here in this terrain. And maybe spin right again, please. And keep coming right.
Can I go a little wider here? Just a little bit.
Okay, just up and right from your lasers now, or just straight right. And then if you could zoom in on that rock just to the right of your lasers now, there's a black rock.
Copy that. Let me get set up, please. Pushing this one a little bit. Does everything look good just south on your camera here? It's dipping quite a bit. I don't want to bump into anything.
Okay, if we could zoom on that one just under your lasers now, that looks like it's got a curved outer surface. That could easily be a tongue of pillow basalt that's been coming downhill. And then zoom out a little bit, please. We just want to get the curved bottom of that rock. And if we could go a little lower with the vehicle, there we go. So that the curved bit at the bottom, what would be consistent, that outer rim where the lasers are right now, would be the chilled edge when the lava was first froze. Okay. And if we could just, if we have the ability to come vertically up from there, pilot, I'd like to follow that uphill, that feature. I think I saw another tube coming downhill above that. Tilt the camera up to look in on the end of that. But if not, just a zoom on this stuff, just to see that would be good. And we're looking at a crack
Chris,
now.
yeah.
Heading is 350 degrees just there. Go ahead, Mike.
Yeah, no, I mean, we agree with you here. I saw that big lump that I think you were referring to when we came down. You know, that was tempting to call it a pillow. You know, I mean, the best guess is that, yeah, these look like little fragments of pillows.
Okay, so if you're happy, Mike, I don't know if I got the orientation of that fracture is along 350. It's beautiful view on the Sirius right now. We should probably record that as a highlight. You can see that big gash through, and I think it's rock on both sides. Yes, that's the one. Thank you, pilot.
Chris, this rock also looks much more rugose than anything that we've seen in the previous dives lower down. You know, they've been nice sort of, they're nice rounded breaks, or they've been very sharp breaks.
No,
this is sort of very jumbled.
Yep, and this is diagnostic textures for pillow lava flows. So we're basically no. I think pilot. I think we're happy. I think the guys at shore have seen enough to be convinced, like I am, that we know what kind of rock type this is. We know what's going on here. So I think we'd be ready to start the first ship move. And we had dropped a marker here already, so that was the wall that we have convinced ourselves is pillow basalts. So the major achievement for the day is achieved.
Can we just zoom in there, Chris?
Oh, okay. Sorry, Nav, before we do. Pilot, we'd like to just zoom in there on, I presume, at the corals. Unless it was at the rocks, Mike.
I was thinking of the rocks, but we'd get the corals too.
My apologies, pilot. It was actually the rocks just to the left of the base of the corals was actually the first request. So if we take our lasers left, and left again, and just there, please. I think there's a dark rock just below your lasers. Mike, if you wanted to go up or down with the lasers, please direct me. That we're hovering as best we can at the moment.
That's fine, Chris. Yeah, no, it looked a little better than I thought it was. I mean, I'm happy to move on.
Okay, thanks, Mike, and thank you, pilot. They're happy on the beach. Yeah, I think for those watching at home, it's the one of the things I've even here with the main screen right in front of me. Those corals are the sponges are deceptive of how dark they are, or translucent. That when I came in from this angle here, the stuff in the distance looked like it was bare rock. I had the pilot drive over there, and in fact, once you get close, they're covered with sponges, just like the stuff in the foreground is. So now we're just setting up our videographers are just taking the opportunity here to take some pretty pictures of the corals there. In fact, that's going to get us some of the nicest close-up of the rocks we've seen yet. You can see very distinct yellow weathering on the right-hand side there, inside the lavas. And some quite smooth surfaces. The very top right corner of the view right now is like an outer surface of a lava flow.
if you get a chance, Chris, if we could zoom in on that yellow stuff.
Yeah, the videographers were being driven for a zoom on the coral at the moment, I'm afraid, but we'll try and do that as soon as we get the chance.
Harvey Nav Bridge, go ahead.
Yes, I'd like to request a ship move to 100 meters, 100, bearing 330 at 0.2 knots.
Copy. 100 meters, 330 true, 0.2 knots. Beginning now.
Copy.
Thanks, that's great.
Okay, so we have some, so you guys in the front row know we have some communication set problems, I think. I'm not sure we've got the now on the EX feed.
No, Chris.
Thank you, Paul.
Only joking.
Quite so.
Is it just you and me at the moment?
I think it might be. I heard Mike briefly, but I'm not sure if he can hear me, and the event log seems to have crashed on both my laptop and on the main computer.
Yeah, guys, we're still off air with the shore at the moment. We're
Okay.
working on it.
So that probably means we're not recording in Seattle as well right now.
Probably not.
Okay, very good. So, yep, Paul, it's you and me and the rocks. So we are on...
I'd better concentrate then.
Oh, yeah, I know. You thought you had the day off, huh? So we're at the depth of 2,200 meters. Oh, the event logs come live. There's a start. EX, this is Rhode Island. Can you hear me yet? So everything's down, but I'm presuming video. Am I correct in assuming that my voice is still being recorded?
Yeah, yes, you are being recorded here locally in the
Okay,
ship,
so I
yes.
shall, Paul, if just speaking into the microphone is going to capture data as well as anything else at the moment, unless you could open a Word file and type into it. But
Yeah,
the time is 15:38 UTC. We're at a depth of 2198 meters, a heading of 274 degrees, and we're facing into a further cliff of pillow basalts covered in all kinds of different animals, predominantly sponges, but some corals as well.
Okay,
These two
yeah,
different
sound is
types of
back, Chris.
sponges, a globose sponge and what looks like a very foliate sponge.
Sorry, was that
cool.
you, Mike, calling from shore?
Yeah, we lost everything and we still don't. Oh, video's just back.
Very good.
So things are coming back. We can hear.
I just lost your audio, Mike, I think.
Just update, we were off the satellite. We're having difficulties tracking GPS satellites due to the magnetic interference.
I'm not reconnecting on the event log. I'm trying through the buddy list again.
No, I think we just have to use audio, Paul, as best we can. We're having trouble with tracking with satellites. It's magnetic interference, I've been told. So
Buddy list just come back.
We're back online at URI.
okay, well, you're back online.
We're up and running here, Chris, as well.
Thanks for that assessment.
So there's magnetic interference. This may drop in and out. So what I'll let you know is when we lose everything, the one thing that continues to be recorded, Paul and I get shut out of the event log as well, but the audio feed from me is being recorded constantly. So what we'll end up with is just a dive tape. It's gonna, in the intermittent periods, we can revert to old school stuff, and Paul and I are old enough to know old school stuff, so we can use audio transcripting later on, just like an Alvin dive. So I will continue to start dictating headings and depths in a very monotonous and religious way all day, because we never know quite when we're going to lose the feed otherwise, and that's the one thing we won't lose. So you do know the for the video, although we're not recording at Rhode Island, we have a backup plan, and we're recording today in Seattle, so everything that gets recorded today, as long as there's any kind of communication ashore, is being recorded. But of course, when we lose satellite feed off the ship, everything gets, the only thing we can do is what we can do. But there's holothurians in the bottom of a lot of these depressions. Well, actually, there's just holothurians all over the place. And we are basically trying to make our way at 0.2 of a knot. You can see in the video from Sirius, you can see how
Dead
the
ahead,
Lurk is
Chris.
getting out ahead, and we have some interesting rocks dead ahead.
Aravina Bridge.
Nav, how close are we to the end of the ship move? Because I think we'd probably like to look at these rocks, please.
1 second. Watch. Go ahead, Bridge.
Yes, 30 minutes to 30 meters to go. 30 meters to go.
Roger that. There are 30.
Okay, I think we'd probably like to stop the ship here if we can, so we can settle up and actually take a look at these rocks as well.
All stop. Copy that.
And pilot, could we have a look at that little gnarly bit of rock that's right down in front of us? I think it's just underneath the vehicle at the moment. Yep. So the vehicle now is on a heading of 029 degrees. We have and a depth of 2194 meters, 2194.7. Nav, could we drop a marker here, please? I believe this will be marker 079. And Paul, maybe you could just make a little hand annotation or open an Excel spreadsheet and just we can tag the entries here. Actually, I'll try and do the same thing. So it's MCR 079, what I'm going to call a basalt cliff. And we're on a heading of 027 degrees and a depth of 2195 meters. And Paul, we can edit this into the event file later on if we have to. Copy that, Paul?
Copy, Chris.
Thank you. Okay, so we have pillow basalt there on the left. The black coloration here is very heavy manganese oxide coating. These are really old rocks, but the stuff we're seeing there, the biology is interesting, but the rocks, it's not so informative. Thank you, pilot. Not sure if we zoom out. I'll just see if there's something we could gain out of that rock that's coming into view top left. Just the curvature, actually, yeah. No, I don't know if we have time as we're going just go over to the rocks in the distance there and see if we can actually get into that cliff face and see anything useful, or... Oh, wow. No, hang on a minute, I'm just looking at the view on Sirius. Those gullies are really impressive. Like boulder shapes. It'd be really neat if those are actual genuine pillow basalts, to actually go in and actually look at the boulders and actually confirm that. So it's that dark rock that we'd like to have a look at as best you are able, please.
Chris, can you estimate the trend of these
I was
gullies?
just going to do that. Sirius is currently looking on a heading of 320, so I think they're pretty much due north-south. Co-pilot, can you hear me? I was wondering if we could just spin the tail of Sirius so we're actually looking right along those gullies. We can confirm their orientation, please. That's great. We'd like to get it straight up and down. And if you could make nature exist, that those gullies are running due north-south as well, that would make the guys back ashore really, really happy. There we go. So our current heading on Sirius is 005 degrees. So that is very, very close to straight north-south, these gullies ripping through the pillow basalts. Okay.
It's really interesting that these sediments here are actually, some of them were in fact lithified, associated with these cracks, which suggests some sort of fluid flow in order to lithify these things. In my mind, at Lost City, I mean on Atlantis Massif, we actually saw lithified carbonate, you know, in rocks that were 1 million years, or actually 800,000 years old. So it suggests some sort of diffuse fluid flow.
Okay, and probably like the stuff we've been seeing yesterday as well, right?
This is unbelievable scenery.
Hey, I'm back. And there's the text to prove it. You know, pilot, that stuff, that dark stuff that's right in front of you there, if we could just zoom in on that, that would be... If this is a...
Looks like nice
safe place.
pillow on the top under that coral.
That's what I'm thinking, Mike. Yeah, just to the left of that coral. In fact, the coral looks like it's sitting right on top of the outer surface of a big basaltic pillow. for those, our heading right now is 0, no it's not, our heading is 249 degrees with the ROV at a depth of 2189 meters. And if we could just lift up a little bit so we can see that upper surface of that rock, please. That's nice. And then you see,
that looks
you
really
see,
business, doesn't it?
Pilot, you see right in the middle there's a little yellow patch there. Just above that, there's a terracing in the rock. That top layer that the Gorgonian the coral is sitting on, then that should be the outer bit of a layer that's about an inch thick. If we could have the lasers on, the way these things form, they're like a hollow, they squeeze out like toothpaste. If we go up and right with the lasers, what I would like to zoom on is that layer, that thickness just there. That should be a different coarseness to the rock below the yellow. And if we could just go down to the right, possibly, Pilot. I know it's not easy, but that outer rim, the rock to the under your right laser there, would be the chilled margin. That's what we'd really like to zoom on, is that outer layer. Yeah, understood. Maybe if we just zoom wide, actually, would be good. But I'm pretty sure that's what we're seeing there, is that was the chilled margin. And then the yellow sediment just happened to be, the reason the sediment could accumulate there is because there's actually a step in the rock. The actual rock nature changed from the outside to the inside.
Let's have a way.
Nav, we have some confusion ashore, so can we drop MCR 081 here as well, please? Thank you, and then that'll be unambiguous.
That's good.
So Chris,
no, that's fine, thank you. Go ahead, Mike.
So Chris, and I totally understand the difficulties, but clearly the cool thing to try and do would be to see if there's a big enough space, if we could get to the bottom of one of these cracks, because that might be where the fluid's coming out.
I'm ahead of you, Mike, and I already know that we can't do that. Sorry. We haven't seen a crack big enough. We looked on the Sirius view, and these cracks are not, the currents here through the cracks probably being funneled by the topography are not the kind that allow us to go down deep inside, I'm afraid. But we'll keep looking for a bigger one.
Totally understand, but if we see a big one, that'll be a cool thing.
Yeah,
to do.
that would be such a valuable thing that we will. We'll keep our eyes peeled. The Sirius field of view is phenomenal for this. I don't think I know any other vehicle where we could have even tried to hope to do that. You know, actually, this rock we're looking at now with the coral, it's going to be really interesting to actually look. I think you can see the kind of the outer layers. You can actually see the depth and structure to the rock, the sort of concentricness of the rock as we zoom in here on the coral. So these guys are going to be having a look at the coral, but we'll have a look at the rock as well before we're done. And Pilot, we'd like to look at the concentric layers of the rock as well that this coral's sitting on when we're finished with these shots, if that's okay. Thank you. Go ahead, Nav. Yep, go ahead, please. Yep. 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 Thank you very much. That's the record I had as well. Thank you, Nav. That's That's really good. Could we have the lasers on for the scientific part, just to look at that rock, please? When you're done. Thank you. And if we could zoom back in again. Sorry, I was distracted. And maybe pan a little, or zoom a little wider, please. So we can still see the lasers. There we go. That's great. So I'm pretty sure that's what we're looking at there is the sloping downhill from center top to bottom right is the outer surface of this pillow, and then what we're actually saying is the layering inside that is probably concentric circles of cooling, a progressive cooling history from the outside to the inside of this sort of route, generally sort of bread loaf shaped piece of what was once molten rock erupting at about 11 to 1200 degrees Celsius. So this is the basalt. This is actually what covers about 70% of the ocean floor. This is, getting back to Paul's analogy, this is what normal looks like. This is actually what we typically expect to find spread across most of the ocean floor with sediment over the top. Okay, thank you, pilot. That's great. Let me see. Paul, would you like some images of the coral? Or is this more for program benefit? Now we're heading forward here. This is fascinating as well. We have basically a double gully directly ahead of us. We are on a heading of 006 degrees. The vehicle's at a depth of 2190 meters. And we basically have a spine that's sediment covered, but with pillow lavas almost certainly is what it's made up of. And you can see that to either side as well. So it's a double fissure with a spine of pillow lavas right ahead of us, and then cliff walls to both east and west of the same material. Plenty of sediment drape, and again, this is a north-south rip. I would estimate, can we have the lasers on, please, pilot, if they're not there? I can't see them at the moment. There we go. So the lasers show you what 10 centimeters looks like. So this is on the order of 1 meter wide, this ridge, and the fissures to either side are also the order of 1 meter wide. Very dramatic geology. And I haven't spent a lot of time on fresh lava flows on mid-ocean ridges, and there's a lot of biogenic carbonate on top of these ones as well. But even so, in terms of fissuring and fracturing along mid-ocean ridges, these are the kinds of things you hear about in textbooks and you don't often get the chance to visualize. Some of the sort of most classical models of how lava injects itself at ocean crust is through sheeted dikes. You can see fossil versions of mid-ocean ridges in places like Cyprus. I just got the chance to see them for the first time about a year ago, where you can see these vertical cliffs, or when you look into a cliff section, you can see these 1 meter wide columns of rock. And the idea is that that's actually about the sort of the quantum amount of how lava gets emplaced at a typical ocean crust during a magmatic stretching episode, is that it shoots up along cracks which may be 10 kilometers long, but only 1 meter wide, full of this molten lava at temperatures in excess of 1000 degrees Celsius. And the lava can either, when it breaks out on the top, it basically freezes on the outside as it hits the 2-degree water, and you get these bulbs of lava. The pressure builds up, they rip open, they push onto the next bulb, and that's how pillow lavas form these great blobs. It's almost like squeezing toothpaste, the kind of texture as they extend out, and each one bursts and keeps going. And those things flow one on top of each other.
Chris, don't want to interrupt your flow, but let's have a marker here.
Very good idea, Paul. Thank you very much. Nav, can we drop a marker here, please?
Actually, thank Jameson. He suggested it.
And that's marker 082 there. Thank you. So that's the kind of thing at any one point on a slow or ultra slow spreading ridge, you might expect that kind of rate of eruption, and even that's an oversimplification, because probably what really happens is you have long periods without any eruptions. And indeed, where we are, the way Mount Dent formed is you may have gone actually 1 million years without any volcanic activity at all, and everything just being tectonic activity. And then at some point you switch back from tectonic activity to volcanic activity, and the whole process starts over. And it's the so moving on. We are now on a heading of, or the vehicle is on a heading of 070 degrees. Sirius is facing 020 degrees, so it's a little bit east of north. Sirius is having little Herc's having a fly around to see what else it can find. Looks like there's going to be another little cliff face just ahead, so that's pretty cool. On a heading of 028 degrees, so again we can see another one of these gully features, unless it's the same one. Maybe we're just coming back to the same place. Nav, how does this compare with our last marker position? Is this coming back on top of the same ridge after Sirius caught up with us, or are we moving ahead? Okay, let's leave that. Gotcha. So we come over the ridge and we come down the other side and we've got more of the same. So we are looking now on a heading of 006 degrees at a depth of 2192 meters. I was just wondering whether I was going to be able to get the...
Go ahead, Bridge.
Yes,
if there was an angle to that, but I don't think it is. I think these fishes are pretty much straight vertical up and down.
50 meters to go.
That's
Looking at that piece we're just going past on the
there.
left.
Yeah. Basically, left half of the field there is a very obvious tongue of pillow lava which comes out and basically hangs over the top of this cliff. So again, we've got this nice relationship that they've got pillows that are fractured open, but some of those, that one in particular, speaks to the idea that it's not a single thing, that it wasn't just one thing happened and then the other. That suggests there was already something for that pillow lava to fall off the edge of, or otherwise it wouldn't have flowed over the edge. But there are others, like you can see in the center, in the distance there on the, just to the left of the lasers. Maybe we can get the pilot to spin round to the left. That there we've got a nice cobble up just right there. We can see pillows there, which are basically the face that's downhill to the right, are just being cut off. So this is more consistent with the rocks having just been cracked open. It's absolutely fascinating. And let's just drive up here and look down inside this. That'll be fantastic. So here we are, right on top of a giant crack in the earth. Oh, actually, can we just hold there and zoom in on that green stuff? That's hydrothermally altered, I'm sure. Okay. But that's really interesting. We can see biogenic carbonate to left and right. We see dark rock in the cliff walls. And this is exactly what you'd expect. If hydrothermal activity is all about how you make water hot, what you'd want to do is crack it open, let the water in, and let the water flow through where the rocks are hot. And I want to believe that that sediment in the distance is greener than the sediment just to your left. If we just zoom out a little bit, please. You can see there's, okay, hold. You can see pale brown carbonate sediment on the top of the hill. Down in the gully, that sediment, I don't think it's just shadow, I think that's actually a different color.
Arabina Bridge.
Maybe as we drive
Go
forward,
down to the
we can
bottom
actually
of
see.
well,
Yeah, 30 meters to go, 30 meters to go. 5 minutes.
If we could find
to
somewhere
go.
where...
Roger that. Can we add on?
And people who know about their cameras here, can you confirm that's a genuine color difference there? That's not a lighting effect? Or might I be deceived?
I think you're going to see
tell
it's
you
a
what,
bit of a lighting
I
effect.
tell you what, if you follow straight ahead where the lasers are uphill from there, let's see what happens when that
Yes, go ahead.
sediment comes up.
Did you copy that last request?
Yes, 100 meters to the present
Certainly
set
some of the
point.
rocks. In fact, if we just zoom in
Alright.
there where the lasers are, those rocks look browner at least. And if that's true, this should be better lit. So we see a lot of yellow-brown staining in the rocks, and above that sediment above there, above the lasers, so just top of the screen there, if we can come up. I can believe that down in the gully we might be in shadow, but that sediment up there, we should be getting to a point where that's as well lit as the carbonate to the left. And I believe that stuff right there under the lasers right now has got a different hue to it, and the rocks all around it, there's a lot more yellow and brown under the lasers there than there is within the field of view. In the top left corner, for example, we have fresh, dark black basalts in this gully. I think this counts as an unfortunate discovery. We're not the we're not the only ship in the ocean, and I guess this tells you can wander around at random when you come to places nobody's ever been to before, and it doesn't mean humans haven't had an impact. That's okay, so we're still progressing over biogenic carbonate. The time is 16:29 UTC, 11:29 local. We are still on our way to the next of our big mounds. We have a ship move underway, and we are heading towards the eastern side of that mound, keeping our eye out for sonar targets. Go ahead, Nav. Yep, now's a good time. Okay, so I've just been talking with the navigation, just getting our eye in. If you're looking in the high pack direction, we're basically going to proceed across now to the next big mound at a timing of 0.2 knots. It would actually take us about an hour and a half to get that far. So that's what we're going to aim to do and start making some progress. We have about, that's about 600 meters away. We have about 1,200 meters for our total line for the rest of the day. So, but once we get to B9, then there's a whole series of lumps. So that's what we're going to start doing now, is progressing over this carbonate seafloor. People ashore, if they if we're not making fast enough progress, you just let me know, and we will keep cracking. But also the same way, let us know if you see anything that you particularly want to stop at. But make sure, since it's Mike or Bobby with the microphone, you're probably going to have to wrestle them hard if you want to look at some holothurians. And what we're aiming for as we approach that next mound is we're going to come by just on the east side, because that's where the backscatter is the brightest. And the plan is that we'll come in about one contour down from the summit and do a fly pass to the east. So we're making our ship moves to head that far, and then we'll hold up and see what we see when we get there. Okay, thank you, sorry.
It's okay.
At the end of this ship move, let's put in a new one, 340, 100 meters, 0.2 knots.
as soon as we reach the end of this?
Correct. You do not need to come to a stop.
Okay, 100 meters, 340.
What's the best way to make that clear for future announcements?
Just tell me to do it from the end of this move.
Roger that.
When we hit the end of this move. I'm not going to wait till we're there. I mean, we're still going to be a couple meters away when I dial it in. So
Yeah,
that
for sure.
I don't let the ship stop.
All's quip within 5 minutes of getting in the seat yesterday was the one about, well, there's really nothing interesting to say about this. Was quite a good one. Maybe we should just have that as a tape loop or a jingle we can just play out here and save our voices. But I think that's something we should think about what we might have, whether it would be something that would be suitable to put up to have votes for, or at the very least, for those engaged in the mission, maybe we can start thinking about that for the cruise T-shirt. And once again, as you can imagine, answers on a postcard, send them to the ship, we'll read them in about a week. There's our lasers. Again, course material at the bottom of the hole. Do we have time? Are we far enough ahead to look down inside that? If we have time for a zoom on the fly. A hole at the bottom of the ocean. Oh. Yeah, if we could just take a quick zoom. And Greg sitting next to me says, don't pull the plug out if you find it at the bottom there, or the water will flow away. And are those pteropods again, Paul, the little white things?
Yeah, they look like it, Chris.
So again, this is like we were seeing yesterday in hollows, that it's this coarse material settling down from the upper ocean, which is probably what makes up most of the sediment. But then, okay, thank you, pilot. Let's zoom out.
You tend to
So I
get
guess
them in the warmer oceans, the pteropods. They tend to be planktonic. And it's very interesting. There's a thing come out recently on the effect of volcanic ash affecting the pteropods and causing mass deposits of pteropods on the seabed.
Can we just feed or somehow take or impact on the seafloor, that there are meant to be things that have been described from other people working in this area of scour marks that were attributed to sperm whales that can dive this deep? What's that on the bottom of that? Is that rock, or is that more coarse sediment under those lasers?
Looks coarse.
It's certainly a different colour. What's the black stuff? Are those animals or minerals?
Look mineral to me. They look like bits of volcanic rock to me.
Yeah. I mean, the white is animal, the brown are gastropods, is that correct? We see white and different shades of brown are gastropod, but there's black fragments there. If we can get a good picture of any of the little black spots, pilot, I'm not sure how well you can do that when you're hovering. Yeah. I tell you what, over on the far side of there as well, you can see a grey discoloration underneath the yellow. That looks like lithified sediment. And distance billets. And that looks like, yeah, the one on the left there, that just looks like that's got an angular bit of rock. Mike, can you see what we're looking at back in Rhode Island?
Yep, we can see it.
And that looks like a little rock fragment. Do you agree? Or can you not see that clearly with your feed?
No, we can see it clearly. We agree.
And, okay, pilot, thank you very much for that. But what I would like to do is look right across the bottom of the crater, because we have these little black rock fragments in amongst the coarse sediment. And as we zoom out further, please. No, straight ahead. You see the top left there? There's like a little cave at the bottom of the cliff. Let's zoom in on that. It looks like this sediment is kind of, it's got some solidity to it because there's an overhang there which requires the sediment to be lithified. Just trying to see if there's anything we can get at that will give us some clues of
RV nav bridge.
how these holes form or what's going on with them there. So you can see.
Go ahead, Bridge.
17 meters from the end of this move.
And if we come up
Go ahead, let's add on another
the sediment
100
directly
meters.
above that, that's it.
340.
And maybe zoom
to
out a
your
little,
current set
please.
point.
Okay.
So we can just see the crack as
340.
well. That's great. So you can see distinct layering in that sediment there, but it's got enough strength that it hasn't collapsed inwards. So you basically got the wall to this little mini crater. So if you've got coarse sediments being left behind, you've got coarse rock fragments. One way you can get this, it's I think I remember Nick McCabe was a professor in Cambridge when I was a student. He had this concept of biological pumping, of why it was that coarse material stayed on the surface and fine-grained stuff didn't. So one theory, thank you pilot, we can zoom out now please, zoom wide. That, for example, if the interpretation is correct that this is fluid expulsion, then it could well be that fine-grained material being blown out, the coarse stuff couldn't escape, it sunk back out into the crater. So this could be a whole thing that's collapsed inwards. But what that would require is that there's angular volcanic material involved in this sediment as well. So that's kind of interesting. We've seen the large pillow basalts, the things that erupt as contiguous things, but I'm not quite sure how we get the coarse angular fragments of dark rock in there. I mean, to be that color, they must be volcanic rock. And navigator, this is watch lead. Can you give me a range to the end of this line, please? Thank you very much. I think the lineations we see, the scour marks, must be biological in origin. There's no coherent pattern to them all, despite my wishful thinking earlier. The pock marks, the circular flows would certainly be consistent with some kind of fluid expulsion at some point in the not too distant past. Well, I guess it must be happening all the time, because if you look at the mottling on the top of the sediment, there's clearly things like the holothurins are reworking that all the time. So you wouldn't actually be able to keep the steepness of the sides of the hill for long. They would get smeared back out again by the biological activity. When they get swept back down again. I know the currents down here aren't strong, but the biodiversation that we see from the holothurians, I bet the whole of the, and you know, there isn't any one patch of the sediment doesn't get turned over within a reasonable time frame. What's that just there? Is that a sponge just to the right of the lasers? So it's not like it's completely devoid of life here, and the mottling effect tells you that, you know, the fact the sediment is getting turned over. So again, if you've got these topographic highs, even if they're just relative of, you know, tens of centimeters, you wouldn't expect them to last forever or indefinitely. So there must be a certain time scale over which, or should have some bearing on the how recently or otherwise that these scours and pockmarks must have been generated. A depression might take a long time to fill in if settling rates from the surface are a centimetre 1,000 years, but the sharp sides we see to where the sediment's been lifted up out of these holes and piled up beside it, and you see those steep sides, you'd expect something different to happen, or expect it to get eroded.
We've also seen these, some of these very smaller diameter but very deep holes.
Mm-hmm.
We've seen the same thing in Yellowstone as well.
Yeah, because some of this, I remember that from yesterday. We were looking right down inside. No sign of life inside. It wasn't as though it's, I suppose it could be an organism burrow, but that's relatively rare.
You know, more related to thermal than that.
Now here's an interesting thing coming into field of view. We have one little piece of rock sticking out from the seafloor. And as soon as we do, look at how life takes advantage of that. So we have sediment all around us for some distance the way we've come. As soon as there's a piece of bare rock, here we have these corals taking advantage, taking a foothold. Comes down to this whole idea. It isn't just true of a question for hydrothermal systems, but it's a matter of, you know, how does life get colonized around the deep ocean? That one of the interests we have from the vent biologists is that we can actually use hydrothermal systems because they have a peculiar need of what they provide on the seabed for animals to colonize and arrive there.
Let's go ahead and add another 100 meters, but reduce speed to 0.2 knots.
Chris, is there any fluid, diffuse fluid coming through this pile at the very first part? I don't know if there's any way to look back, but it looked like there might have been a little bit of diffuse flow back at the very beginning of the
We'll
rock.
have a look.
Perhaps I was just hyper enthusiastic.
Yeah, time to go, Tom.
Thanks for looking.
We are heading, both Sirius and Little Herc are currently heading along 340 degrees. We are progressing swiftly over the seafloor at speeds approaching about 0.4 knots, much faster than our usual survey mode, traversing thick biogenic carbonate sediment. Just from our remote sensing techniques, things like the multi-beam and the backscatter we have from the ship, which can cover swaths of several miles wide at a time. We can collect at 10 miles an hour as we're driving, so we can collect very large areas overnight and then come down to small subsets of that and pick particular routes like we're doing today to go through some of the apparently more interesting features and see exactly what's down there, what the geology is, and also, if we're lucky, what kinds of interesting life might be down here as well. Line the ship's on, is that offset by, is that a large number compared to the 100-foot length of our tether? Okay, well maybe, pilot, maybe what we could do is if we could bring Sirius uphill a little, and then track along as far off to the right from Sirius's line as possible. Let's not change Sirius's line, but if you look at those, this move is working beautifully because there's our first rocks for a while. Rocks in sight.
Little Herc sonar looks good too, Chris.
Say again, please, Nav.
I was just saying,
Yes.
Little Herc sonar looks good too.
Yep, let's do that. Let's stop the ship here then, please, and settle up to do that so we can look at these. Yep, so you can hear in the ECC, our corrections come a little bit too late to look at these rocks. We're actually going to need to stop the ship and move it over to the east. My apologies, I didn't pay attention to this earlier. So if you bear with us, we
Not
will settle up.
accepted.
Okay, I'll just wait for somebody to swim out here and replace me.
Go ahead.
Oh, this is
You're doing a great job.
very
Roger
interesting.
that, come and all stop.
And we just about caught this in time. At least we drove up the hill and didn't drive right past it. That's my claim to competence for the day. It's as close as I'm going to get. Some very interesting features there. can we, while we're just settling out pilot, can we just look around to our right? Or is that just not, okay. Some very interesting features there, Mike, if you're looking at home on a Sirius field of view. Little Herc is on a heading of 020 degrees right there, and we're back in some of these fishes again like we were looking at before. Nav, if I
Waypoint,
can
Chris?
distract you, can we drop a waypoint here, please? This is definitely going to be a good place to stop the ship, and yeah, I think just stopping the ship here will be, or as close to here as we can, and settling up, and we'll come back and have a look at this in some detail. Well, this is interesting. Look, there's sediment, and then there's basalt that's higher than the sediment on top of the ridge. So keep typing your observations as you see them in the ECC. As soon as we've got settled up, then we'll be able to come back and await instructions of what you'd like to go and look at next. But we're just going to get ship and vehicles all in a stable configuration before we do anything else. Oh, okay. That's a long way down. Do we have an altimeter reading for the ROV? How deep is the hole underneath us? Okay. Okay. So we have about, yep, we have about 5 meters of water underneath us. So we're sitting here right on the left of our field of view with the ROV is the seafloor that's right next to us. And then you step across about a meter to the right, and it goes downhill a long way in a hurry. And that looks like all sediment on there. We can't actually see any rock exposed as you look down there. And where do you lose bottom lock? That's okay, it just didn't get a hard return. And Mike, I'm presuming we're correct that the next thing we'd like to do would be to go down and look at those rocks where we dropped the marker, correct? The one over to the left does look like a big hole, doesn't it? A big circular hole. If you've got time, so while other things are settling out, folks, just so you know, you can see in the Sirius field of view right now, there's a circular pit at the top of the hill that's about the same size as Little Herc. And it looks like we can actually reach over there while we're waiting for other things to settle out. We've got to hang out here anyway, so why wouldn't we? So you can actually see concentric terracing. I mean, it looks like in miniature, it just looks like a open pit mine with multiple layers down there. Let's think, if that's 10 centimeters in the lasers, then this must be more than a meter across. Each of those terraces is 10 to 20 centimeters from the inside to the outside, so it's concentric rings. Can we zoom in on those little holes in the wall there? And the strangest thing. Because those things work all the way up the side of the face there. And they blow out and they have kind of like teardrop staining coming down, or not staining but scouring. But for all the world like things have slumped downhill.
Chris, orientation of the face?
The face right now, we're on heading of 355 degrees. We're at a depth of 2108 meters. And the vehicle's just about a meter off the bottom now, so we're very close to we're sort of low down inside the pit to be looking at this. And video, what's the angle down from the horizontal of the camera right now? Oh, sorry. 35 degrees down. Thank you, pilot. So we're still looking down into this thing. If we panned the vehicle, if we panned the camera up to look horizontal, are we too high up that we'd look over the top of these things, or could we try and look into them? There we go. Let's see if we can zoom into that one there, straight ahead. So we now have the camera horizontal. Edward Munch, eat your heart out. It's the scream on the seafloor.
Chris, people here think that they might have saw something in the holes further down, so we can pan down again.
Pilot, if there's a way we can actually look in some of the holes further down, people are sure thought maybe they could see things in the holes, and I bet we can't come down with the vehicle, but if we can pan down and check out some of the other holes. So let's zoom in and see what we can see. I see tentacles on the left. Little pink tentacles in the hole on the left. They're alive. Huh. I think we need a biologist to tell us what we're looking at here.
Animals.
Very good, Paul. Animals. With that, I think it's time you came down here and took over the hot seat for the rest of the dive, if you don't mind, Paul.
I think, looking at the shape of the burrows, these have to be crustacean burrows of some sort.
Okay.
And that does look a bit like tentacles, or antennae, should I say, of isopods.
Okay. And then for scale, I think if we see the lasers, that's a 10 centimeter spacing, so that's just a couple of centimeters across and not anything particularly huge, whereas the hole is quite a... So then that might be colonies of a whole bunch of them all living in close proximity. Okay, so if we could just head back down to that marker 85 site, please. So
Did we get a waypoint here, Chris?
I'll get one just now. Nav, could we drop a marker here as well, please? That's right, MCR086 is the crater with the burrows. So this is where we're going to hand over the watch lead. Paul Tyler's going to be taking over from me, and he will be with you for the rest of the dive. We're just repositioning to the MCR085 waypoint, where we saw extensive lithologies or extensive outcropping of what we believe are pillow basalts, including some more interesting rifts. And I'll be looking forward to enjoying the view from further from the control room.
Go ahead.
Point 1 or point 2? Point, okay. Ship move, please.
Okay.
60 meters, 160 degrees, 0.2 knots.
60 meters, 160 degrees, 0.2 knots.
Thank you.
Starting now.
Okay, Chris, private line. Yeah, hadn't turned off the mute. No problem. Okay, folks, there's a lot of discussion going on between the pilots and the navigator at the moment. This is exceptionally vertiginous terrain, and they're really just making sure that one, the tether doesn't get snagged, and that they know exactly where they are in this terrain. This may take a few minutes. You can't rush these manoeuvres at this depth, operating essentially three vehicles, as Chris has explained. The ship at the surface, Serios above the site, and Little Herc right on the site. You can see here, this looks very like the face we saw at the beginning of the dive. Looks as though from a distance you can see an octocoral there off to the left, nice little gorgonian, what looks like a number of sponges and other things draped on there that we're still not quite sure what they are. There's been various discussions whether they're bryozoans or whether they're just very, very platy sponges.
Good afternoon, Paul.
Good afternoon. It's really interesting for me, who works on population maintenance and reproductive and life history biologists, just to see virtually every piece of rock seems to have a gorgonian growing on it, suggesting that there's a lot of larvae around here, a lot of dispersal, and they seem to colonize, quite a lot of the rocks. And the same with the sponges. Just about everywhere you look where there's an exposed rock face, there appears to be some sponges, and these very delicate grey blue looking sponges are very fine walled. When we go up close to them, you can see the very delicate structure where the water is pumped through and the particles in the water are filtered off and used for the tissue of the sponge. But also notice how the gorgonian corals have to have a hard substratum. They rarely settle in soft sediment. There's another closely related group known by their common name as the sea pens, and it's rather unfortunate we've not found any of these, but these sea pens live in the soft sediment. whereas the Gorgonians themselves have to live on hard rock. Pilot's just lining up now to go in and have a closer look. As you can see, this is not Formula One, this is much more careful than that. Mike, can you see the structures from where you are back on land?
Yes, Paul. My guess would be it's similar to what we saw at the start. You can see just actually to the bottom right some rounding on some of these the rock surfaces. I'm guessing it is the pillar basalts again.
I'll ask the pilots to zoom. Can the pilots zoom in on the browny looking stuff, please, if it's at all possible? Oh, that's very nice for the sponge as well. I'm not sure anyone watching on base will know what this sponge is, and I'm not sure that's a platy sponge or whether that's a bryozoan that we're seeing there. You do get these foliate bryozoans and these foliate sponges. I'm inclined to think of foliate sponge at the moment, but I'll be happy to be corrected. I think I can understand the frustration. Oh, Mike, it looks more fragmented to me than earlier on, but no, it might be just the different screens I'm looking at. Do you get that feel at all, or as though this has been either more damaged, or is older, or is more cracked up, or something like that?
Paul, this is Chris. I was just wondering from what we're looking at there whether it was a lot blacker with manganese oxide coating.
Yeah, certainly. I would agree. It's a different colour, but also it seems a slightly different texture, sort of a smaller texture to me. Yes,
What we did see is on the top of this kind of area when we first saw the rocks, there were some quite angular bits, which I still think are probably basalt, but they were slightly different to the pillows we saw earlier.
Mike, it almost looks the sediment veneer right at the top of this pile even looks cobbled, just like as though it's a very thin sediment dusting over the basalts there.
Yeah. Hang on, Chris. We've got a lot of talk between the pilots. Ship movement is almost complete now. It looks pretty solid to our right, doesn't it? But it's covered in sediment. Here we have another whip coral coming up. Looks like it from a distance. Some rock behind. Still got a lot of sediment in this area. Can we go in and look on that? That looks slightly different. It might be the sediment covering, but the colour of the rocks towards the top of that little pile looks a little different to me. We're just going in to look at this pile. Just going in to look at this pile, this small outcrop here with the large Gorgonian to its right. The colouring looks different to me. I'm not quite sure what it actually means. As I said, I did geology 40 years ago, but those two pieces at the top, either side of the centre of the screen, I could be convinced they were weathered pillow lavas, but no, someone tell me otherwise. Oh.
Guess I would have to guess it's darker carbonate, but maybe I'm wrong too.
Yeah.
What's our heading just now, please, Paul?
The heading is 337. Yeah. After you've had a look there, can we look just above there, please, pilot? It looks to show some interesting structures in one of the hub. That's the pilot cam. Yeah. What do you think this is, Mike?
I mean, to me, this looks like lithified carbonate that's kind of breaking up and falling down slope. So those are like little lumps of lithified carbonate.
Oh, there's a nice bit of stratification just there as well. But this is not really what you're looking for, is it? Or is this
Yeah, we'd prefer looking at the darker stuff if that's okay.
Yeah, that's fine by me. I have no problem with that. I'll ask the pilots to find you some more dark stuff. Pilots, can we find some more dark stuff? It looks like darker the better today. They're really into the very hard stuff. This looks quasi lithified to me. Yeah.
Well, the interesting thing here is, why the carbonate is firstly lithified, and also why it's so thick, and whether that's, its location in the Caribbean. Do you know more about that?
Not really. I know when I was reading about the geology of this area, there are some carbonate bands, but I think they go back to the Carboniferous, and I didn't expect them actually on top of Mount Dent. I think they're the bits that are sort of bordering onto either side of the Mid-Cayman Trough, rather than actually in the trough itself.
Sure, yeah. No, this stuff must be all 1 million years or less, I guess.
Yeah, that's interesting.
This is just Chris with a thought. That layer where we saw the horizon in the sediment was actually a much browner orangey colour, wasn't it?
It was, yeah.
Which would be a metal-rich horizon.
Oh, post-hydrothermal deposit?
Or hydrothermal plume fallout and sediment, maybe?
Yeah, same thing, yeah. That's what I meant. Yeah. Bit like
just for reference, we saw some of these types of deposits associated with the carbonates on Atlantis Massif at 30 degrees north on the Mid-Atlantic Ridge, and in some cases they were very, very fine particles of volcanic glass, almost hyaloclastite material, interlayered in the carbonate.
Thank you. Mike, is this wall of interest to you to go up it and down it a couple of times?
Yeah, Paul, I mean, what we're trying to do is get the big picture here. I mean, I'm guessing, just if we can continue to go down is my guess, and I know that might be difficult, but, just trying to get a feel for the big picture of what's going on here.
Okay. What I'll do to begin with, Mike, I think I'll get the pilots to transit left here and then see if I can get them to go downhill a bit.
And Bobby,
sounds good.
Bobby, to pick up on your comment just now, talking about hyaloclastites, I mean, that's implying explosive volcanism at the seafloor?
It's possible. Again, it was glass. It was interstratified.
Face the rock, please, if it's possible.
It was glass and it was interstratified in the carbonate, and the question is if it's broken up pillows or not.
Without my lateral function, I had to turn away, drive, and then turn to face. So don't think I'm running off and leaving you. So moves left and right will be a two-step process.
What's the heading right now?
Understood. The heading at the moment is 193. Because I've asked to go lateral, they're having to move off a little bit first and then come in on the face. So please be patient, folks.
That's fine. We were just wondering the strike of the crack.
Okay, I think we'll see. We'll just take some video of this face. We'll zoom in when he's settled. Heading now is 24250. Looking more or less west-southwest. Looks like there's quite a lot of sediment coming.
045 degrees, 10 meters, 0.2 knots.
10 meters, 045 degrees.
No, this is really nice, Dave. Just going over this and just gently. So, because they'll most likely replay this sort of video many times, so to pick out features every time. Actually, these blocks seem more angular to me than we've seen as well, Mike and Bobby. They don't seem so broken up. They're smaller fragments than we've seen, but...
Yeah, these look like some of the very first things that we came across, which were just sort of an angular rubble pile of clasts that were fairly uniform in size, but very angular, so 10 to 20 centimeters across, fairly subequant in geometry. And there's just a giant sort of cemented, rubble pile.
Yeah. Sorry, Bob, I didn't catch much of that. There's a lot of crosstalk going on here while they're doing this. Okay, we've gone up the cliff here. What I'd like to do, if it's at all possible, please, pilots, is go down and keep going down till we find the bottom.
I was at a local bottom, and I will go back to that. Marshall, we came up from the bottom of a long rise of sediment. This was the first set of rocks we hit. We backtracked to get here, but we kind of overshot it. There should be a whole lot more downhill of this set of rocks.
Thank you, Nav. I'll pass that message on. So if we can just carry on, I see some rocks and some Gorgonians ahead of us. If we can follow along and just look at all this here, I also see what looks like a little valley coming up. Bobby and Mike, I've just talked to the Nav. Basically, if you go much further down, it's all sediment. This is the first rock they found after coming up from the deepest part. So what I'm going to do is track along here and just see what we've got. There's quite a bit of exposure just here, so I think we'll spend a fair bit of time looking at this. If you're starting to think, no, we don't need to spend any more time here, just let me know and I'll see if we can move on a bit further. There's also some
Sounds good, Paul.
Also quite nice biology here.
Sounds like a good plan.
Just going to swing my head around Paul here and get the lay of the land.
No problem, Dave.
This is a classic trap.
Oh. Oh, yeah.
We may or may not be able to get all the way down there.
In fact, it looks interesting both sides, both to your right and to the bottom left there.
No, bridge.
Where it looks a more vertical face, but I do appreciate there might be a hole you don't want to go into. We're just getting an idea of what exactly, where we are, what's the size of the hole. As I said yesterday when we were talking to Dave, when we were looking at delicate places to take the ROV, no, we do not want to lose an ROV. We've been down that path once this year, and we're not going to do it again. Gosh, Bobby and Mike, do you think that boulder has slipped off from further up and gone down and got jammed in that sort of groove there? Or do you think that's actually somehow it's eroded around it, or it's a fault?
I think what you said first, Paul, that's broken off and rolled down there and just got trapped there.
Yeah, okay. Yeah, so that was my first part of my question. Forgive my geological ignorance here. I did mainly stratigraphy as a geologist, working our way up through the different strata rather than structural geology.
Paul, I think, in a way you're absolutely right. I mean, I think what we're probably looking at...
Say again, please.
Paul, I think you're absolutely right. I mean, I think what we're looking at here is literally a big crack or fault that's, breaking this stuff up. I mean, it's a little old because it's kind of sedimented, but basically, stuff is rolling down the fissure.
Yeah, okay. That's good. Anyway, we're turning in to have a look at the wall again now. What I'm trying to do is get the guys to look at the wall on this side, and then just to the right of that, what looked like large boulder we thought had rolled down the hill, there's a fairly flat face that I wasn't sure had that much on it, and I thought we might get some better geology by looking at that face. The bearing of the ROV at the moment is 253. Okay, Mike, we can't actually go into this hole. It's too small, but what I'm going to do is try and get them to set up out of the hole and then go in with the zoom, if that's possible.
Sounds good.
Bearing of the camera is 275. Sorry, it was 175. Nav, it will be, I think, be useful to have a fix here. Please, I would make it 086. Oh, it's still 085. Thank you very much.
So this is probably something like this because there's a transition.
That will be good. When you're settled, we'll zoom in and have a good look.
There's the sediment, and it looks like, I don't know if it's shadow or some other kind of rock.
Okay, Mike and Bobby, I'm not sure if I hope you can see this clearly. There's a nice little tower here with what looks like partially lithified sediment on top. Actually layered, you can see the layerings, we're getting closer, and then there appears to grade down into, I suppose it's a rubble of some sort. Can we just go down a tint, Dave?
Yeah, Paul, we can see it very clearly.
There, they can see it very clearly, Dave, so this is good. There's absolutely wonderful collection of gorgonians around here. And these gorgonians are, I'll talk about the gorgonians a bit while the geologists are feasting on the eyes on the geology. Gorgonians are an incredibly interesting group of animals because what you tend to see is the little polyps, rather like little anemones right along the stem. But they're all joined up, these, and they're joined up by a tissue called coenenchyme. And the food that's taken in by any one of the polyps can basically be passed between the different polyps through small channels in this tissue. And the tissue is very, very thin, so you can't actually see it. But if you put your finger on one of these things, you can see that there is actual tissue over what looks like all these stems. So the polyps are interconnected, and all of them, every single one in this group of octocorals is colonial. Like all the polyps are part of one individual. And the other interesting fact, each one of those polyps in that whole colony is all the same sex. They're either female or they're male. And
can we zoom in right here, please?
say again?
Can we zoom right here, please?
I can't always understand what she says. It's so clear. Oh, okay. That looks like hydroids on the edge of that lip there. I can't think what else.
And can we move up slowly?
Yeah. Now that's interesting from what you were saying earlier on, Bobby. You were talking about sheet lavas, I think if I remember rightly, half an hour or so ago, and that looks as though that was quite flat. We've seen those sort of sheet lavas in some of the vents in Antarctica, where they make it all platey rather than pillows.
Right, I think you probably get pillows and sheet flows and they overlap each other with time, and so you can get quite a variety within one sort of pile.
Oh, right, okay. Interesting.
Really depends on where the actual vent is and if the vent moves on the seafloor and, whether they're coming out of a lava tube or not.
Paul, did you get confirmation from Nav that we dropped marker 86 there?
No, we didn't. We're actually still bang on 85.
Understood.
Chris, I did request another marker, but Nav says we're definitely on 85 still.
Understood, thank you. We'll correct the event log.
Listening, Chris. Okay, Chris, so what do you want to do? I just want to ask the ship to move at 0.2 of a knot, warn the ROV crew that we're going to be moving. And this is going to today's station 9. Okay, mate. Hi, Nav. Paul here. Just been having a quick conversation with Chris. I think we'd like to start moving the ship at 0.2 of a knot, going towards station 9, and see what we see on the way. Yep. No, the former, I think, please. I think we are, yes. I know. I get the impression talking to Mike that unless we can find something where there's a clear indication of the rock, we need to move on a bit. Moving off at 350. We're going to start moving now from today's station 8, which was in fact marker 85, and we will start moving towards today's station 9. Okay, folks, we're starting to move again. Little time getting things organised. We're going to move at 0.2 of a knot. Essentially, there is a large mound in front of us that we're going to skirt round to the northeast of that, so we just don't go over a big pile of sediment. We might find something on the northeastern side. I'm just going to ask that, Chris.
Yeah.
130 meters, 350 degrees, 0.2 knots.
130 meters.
Time to the station 9,
yeah,
please, Nav.
350 degrees, 0.2 knots.
Affirmative.
Starting it now.
Chris, just out of interest, we do have a station 086. That was the holes that we found after we found site 8. So we went from 86 back to 85. So the next marker that we put down should be 87.
Thanks for that, Paul. That's probably why I saw a marker 86.
Yeah. Okay, here nice. Looks like lithified carbonate. Again, to me, as a non-geologist. Nice pink Gorgonian. It could be Paragorgia, the bubblegum Gorgonian. Have to get closer to have a look at. Very steep just here.
What's the heading just there, please?
Heading is 24. I see. Can we go? Chance to look it up? Are those, Mike and Bobby, are those sort of sedimentary channels running down where loose sediment just goes down and essentially forms its own little grooves?
Absolutely, Paul. Absolutely.
Okay, I've seen that. I've seen those in the Bahamas.
A little bit more information on that. Those lights burn at the same color temperature as sun, 5600 Kelvin. And that's why we use them, and that's why we get the color almost as true as we could possibly get it in with the high definition cameras. And each light has its own ballast, and the light and ballast make one set, and that set is about $40,000 each.
Okay, there you got a good explanation,
that's fine.
folks.
We can easily.
Yeah. I got the basics right. They're expensive.
Yeah.
So we look after them.
Yep.
That's fine with us that we are in the dark for a while. Not a problem. We don't need Chris to tell us that we're always in the dark either.
I was going to say, if there are any problems, just charge it to Chris.
If I can chatter on for a little bit to you, Mike, and Bobby for that matter. No, I was looking at the dive plan today, and I was just gobsmacked. sorry, English expression here about the number of faults that run across the top part of this complex. And are these mainly from sort of geophysical observations, or are these from visual observations, or what?
Those are all picked from the bathymetry pool that we've been collecting. And it's actually what's interesting about this particular ocean core complex, in that it is much more dissected by these faults than you see in, say, the ones in the Atlantic, etc.
Oh, interesting, interesting. You intuitively, again, as a non-geologist, I would expect a slow-moving centre to actually have less faults. Because the stresses and strains. But maybe it's like Chris said, it moves, 100 centimetre a year, but that, it's 100 centimetres once every 100 years. So therefore, it's actually pretty serious when it does move.
Yeah, that could be exactly it.
And the map, the faults on that map are just sort of the biggest ones that we recognize, and there's probably many, many, many more.
Oh, wow.
Like these through the cones that we see today. We haven't mapped those at all, and so we're missing sort of the really fine scale stuff that you could get if you have an AUV driving around and actually doing the mapping very close to the bottom.
Good heavens, that's just incredible. I don't know if the people that are on different sites have seen the dive plan for today. I know I posted it out to friends in Southampton. Essentially what we have on the first sheet is a map of the top part of the Mount Dent, covered in 12, 14, some continuous, some quasi-continuous black lines representing faults. And what we're doing is really running along one of those faults, because that's where hydrothermal activity may be. And this is all part of the exploration plan for trying to find hydrothermal activity over Mount Dent. But we're not finding much hydrothermal activity at the moment. But one thing we do find is octocorals. And I don't want to show any bias here, but I'm happy to go on a dive that looks at octocorals. And for those of you that have joined us, recently or haven't been listening to previous days, one can get a feel of the currents here. You see octocorals are spread out like fans, and the current flows what we call normal to the octocoral, so it flows across the face of the octocoral, and so the polyps spread out to gain the maximum number of particles that are brought past the octocoral itself. So we can get some idea of the direction of the current, even if we can't figure out the speed. And for those of you that have access to the Sirius video, you can see really it is quite hairy terrain that we're going around. The pilots have to be careful that they don't end up going up a little dark alley somewhere and they can't get the ROV out. So you can see it's quite steep. Not a great deal of rock outcrops just here. Quite a lot of sediment, but very steep enough to have what looks like just gravity sediment flows, little trickles of sediment running down and almost forming waterfalls in some places, I expect, as the sediment migrates downhill. There we're looking almost down the throat of an octocoral. These are often called whip corals. There's all different types of whip corals, but when it's a single stem, the generic term we use is whip corals. When it's multi-stemmed and branched out, like we saw a couple of minutes ago, those are called fan corals. But unfortunately, each of the families in the Octocoralia tend to have both whip corals, fan corals, and just about every form in between. So it's not an easy way of identifying them. That seems a very steep wall. That seems a very steep wall in front of us. Or is it just my imagination? Except I hope in a Piper you would be going faster. One thing that's worth looking at on the sediment, I had an email from a colleague this morning saying, I think Chris passed a comment about sediment not being frantically interesting, and I think I heard the gasp from 5,000 miles away. And my colleague suggested, Dave Billett suggested that he thought he'd seen xenophyrophores, and these are really interesting little animals that live on the surface. They're single cells, but they can be up to about 4 inches across, and they appear to be partially embedded in the sediment, and they stick up above the sediment, and they're called protozoans. They go by the wonderful name of the Xenophyrophoridae, and xenos to those that work with them intimately. And we have one of our colleagues in Southampton specialises in this group, and he's out in the Atlantic at the moment, I suspect, collecting these and pouring over them with great intensity. So I'm going to look out for xenophyrophores. I think I've seen a couple, but these don't seem to be the size that I've seen before. They're generally just a couple of centimetres across here. And the other thing, of course, is we might not be able to see things on the sediment, but I expect the sediment is most likely containing a lot of very small organisms, and it's the sediment that does give rise to the biodiversity that is now proving to be very high within the deep sea. And there's most likely the deep sea is going to have a higher biodiversity than any other environment on Earth. One of the things I talk to with my students is that the tropical rainforest is always considered to have exceptionally high biodiversity. But if you find a new species in a tropical rainforest, the chances are it's going to be a new insect, and even greater chance it's going to be a new beetle. If you go into the deep sea and you find a new species, it can be one of something like 30 different phyla. And the phyla, of course, is the largest grouping in the animal kingdom, and so the diversity in the deep sea is just staggering right across the animal kingdom. Looking at the sonar, we have some pretty solid looking stuff in front of us, so we're progressing steadily to make sure we don't go careering into something.
Can we turn the ROV to the right to look at the rocks?
Can we turn the ROV slightly to the right to look at the rocks, please, as a request? Okay, Bobby, the pilot's seen something that he thinks we will be interested in.
Pilots we trust.
All right, in pilots we trust.
I don't know, I find it just amazing the pilots seem to see things, at least 10 seconds before we do.
And about 20 before we do.
Yeah. The solid stuff seems to have gone off to the left here now, Dave, on the sonar.
Yeah, that's the territory ahead, and we'll be getting left of me is our direction of advance.
Yeah. Okay, no problem. I suspect if my wife was listening, I would be getting an email telling me to be more patient. Okay, we'll have a look at this face. Bobby and Mike, this looks pillowy to me, or is that carbonate again? I'm just looking at.
No, there's definitely pillows down there, and then there's carbonate on top, and some of the carbonate looks kind of brown again.
Oh, nice, Dave. Gosh, it looks as though it's just hanging there.
It's a beautiful pillow at the top of the screen.
Apparently, it's a really nice pillow at the top of the screen. I guess that's it, right? Almost in the center. Excuse me, almost in the center of the screen. Now, is that right, Mike?
It's now coming into view now. So the thing that's just about in the middle of the screen now.
I gotcha. I think slightly to the left, if possible, please. Is that coming into the screen now, Mike? Is that what your top left?
Yeah, top left. If we could zoom, sorry, top right.
Oh, the
Right
top.
and.
Hang on, which side do you want zoomed?
Top right and zoom out, if that's okay.
Top right and zoom out, please, pilot. How's that, Mike? Is that good for you?
Looks good.
We've got to go. We've been tugged away. Thanks, guys. That was good.
Thank you, guys.
Okay, folks, we're moving off again. We're moving towards today's station 9, and we're here at the top of Mount Dent. Coming up here, we have a nice cliff to our left. I'd say 5 meters or so high, covered in Gorgonian sponges. We're just turning around, and then I think they'll turn into it. If you look at it from the Sirius, you can see it's really quite tall. You can see the ROV turning around, doing this anti-clockwise spin, now facing the face of the rock. Lots of Gorgonians, nice big round sponges, typical filter feeding community. Just what you might expect on rocks in the ocean. I think the things that surprised me really about the rocks here is what's not here. And I'm quite surprised we haven't seen any stalk crinoids, and we haven't seen any commatulid crinoids. These are sea lilies. And these are very common on rocky surfaces in the deep sea, and it could just be that the larvae from these animals have never had the opportunity to come and settle here. But it's a very rich or very high biomass fauna here. Lots of sponge, large Gorgonians, very big circular sponges. For those of you that aren't familiar with sponges, what you can see, the bottom right-hand corner is a globular sponge, and that hole that you can see is not where the water goes in, but it's where the water comes out. And what we have there is there'll be lots of small holes all over the sponge that water is dragged in by flagellae. The particles are taken out, and the water, what you might call wastewater, is then pushed out through that top hole. Mark, they're just getting themselves organised with the tether at the moment. I'm not sure it's going to be that easy to see what's on the surface here because it's covered in so much in the way of fauna, particularly those sponges.
I agree.
There's times when I've been with geologists in canyons and we wanted to have a geology hammer to smash on the canyon wall. Okay, we've got to move off by the looks of it. I think that the pilot's getting, the ROV is getting dragged. Another large Gorgonian. Heading is 350. Almost a nice large lump of rock. Very rich Gorgonian fauna. Pilot, it might be nice to get both video for geology and video for biology here. This looks very spectacular. Yeah. But that is very nice. I'm not sure what you can see there, Mike, but we're just going very slowly past it. We're not settled, so it's not that easy. There we go. Looks as I'm not sure what the yellow is. Is it sediment or is it weathered rock?
I think the lighter color is probably sediment.
Yeah.
But
Okay.
the interesting thing is, maybe the amount of fauna is telling us a little bit about the history of these spaces, in that we're seeing, slightly older and slightly younger fault scarps, and the older ones are more colonized, and so on and so forth.
Yeah, that could well be the case. This certainly is a spectacular spot in terms of the fauna here. No, I have no idea whether these are the same species, or no. Just looking at the structures, I think there's at least two there, and maybe seeing that whip one now, there must be three there. So this must be a good spot to live. They must be getting a lot of particles. Maybe there's a good flow past there, and therefore they can grow quickly. Did I hear the word cranide?
Should we get a marker here?
Good idea. Come here. Nav, come with a marker here, please. .087, agreed. Oh.
And that's marker 087, is that correct, Paul?
Yeah.
Yep, I'll type it in for safety.
I see my event log's frozen.
Okay, you've come through okay, but you might just need to log out and log back in again.
Yeah, try that.
If not, just dictate away and I will stenographize.
That's what I like to hear, but don't do it in public.
Go north and discover something, young man.
Nav.
Yes, the ship is contacting port stop. There's one more move I need to make to get to the next waypoint. You want to explore here, or do you want to get moving to the next area?
If there's some hard substratum, if there's some hard substratum, I'd like to explore here.
Okay, so the vehicles are Sirius is still moving to the main front, so it hasn't stopped yet. So I'm not going to make a move until it carries out a little bit more.
Try taking some red.
So pilots, did you copy that? If there's hard stratum, your assignment's going to want you to explore this area. Explore.
Okay, we're just staying here for a bit to explore to see if there's any more hard substratum while they get themselves into position to move off. Tell me, Rhode Island, are you guys, are you still into the event log at the moment?
Yes, Paul. We saw that you typed 087, etc.
It must be just mine that's frozen here then.
Paul, I think actually we're out of it now.
Thanks so much.
Okay, we're back in.
Yep. Okay, the heading is 250. You'll have to type for me, Chris. I'm getting nothing still. Okay.
Real-time data's down. Oh, you're in.
Ah. Thank you very much. Okay, folks, this looks like another fabulous biological site. Sometimes I just have to sit here and just say, wow. We have sponges, whip corals, other gorgonians, branching corals. Those are like sponges, things we're still not sure what they are. You can see one down to the bottom right there, almost a veil, diaphanous even, in maybe a bryozoan, just maybe a very thin sponge. I'm not sure how much geology we're able to see under this covering of animals. Just slightly to the left, I think, please, pilot. Can you see a bit more there, Mike, to the left? It doesn't seem to be quite so cluttered with animals.
It all looks pretty covered to me, and the lighter stuff is just the sediment, just covering up what the biology doesn't cover up.
Yeah. If we can keep moving to the right, I think, please. Sorry, to the left. To the left. Yeah, I I see in the top left. Yeah, just below that Gorgonian. Uh, as yeah, just keep going this way, please, guys. Seems to be a bit of an edge there, Mike and Bobby. They look pillowish to me, but if we can bring the bottom left into the middle of the screen, please, Dave. Yeah, keep videoing.
Yeah, Paul, I definitely made a note that they look rounded. You know, small pillows maybe.
Yeah. See the ones just at the very bottom of the screen, Mike? There's two. There's one there that's quite dark, and then there's one below it that, struck me as quite round. Just coming into view now. Those two there struck me as, I've looked at a fair number of pillar lavas looking for hydrothermal vents, and so, I promised I never wanted to see one again.
That looks. I agree, Paul. I think that's a good description.
Look up at the top middle of the screen. Now almost in the centre of the screen now. Very round, looks like fractured pillar. Or maybe it's just my imagination. Oh, this is nice.
It looks like we might be sort of looking end on at smaller pillows.
Yeah, just to give you the thing, this is bearing of 337. I'm hoping this is giving you what you want, Mike. I know there's a lot of sediment drape. It's just it's been here a long time. I don't think these are particularly eutrophic waters above here.
And no, Paul, this is great. Thank you.
Oh, and yet another different type of fan coral. And on it, it looks like a brisingid initially, but it looks almost too slender. It's a crinoid. Oh, isn't that lovely? That's a comatulid crinoid. Two types of crinoid. These are related to the starfish and sea urchins and the holothurians that we've been seeing, and they are very primitive. And what they do is these arms form a basket and they take particles out of the water column. And the indications, the way they're holding their arms, the particles will actually come, or the flow will come from the left side of the screen, and they form this basket and take the particles out of the water column. Often brightly coloured, even in the deep sea. And that looks like that sort of almost lithified rock again with banding. Chris and I were talking on the private line just now. Is that hydrothermal deposit from hydrothermal plumes in the past? That even looks like a fault running through there as well. Very nice, guys. Very nice.
Paul, you and Chris are the experts on the hydrothermal stuff.
Say again? So I missed that.
I was just saying that you and Chris are the experts with the hydrothermal stuff.
I might know the animals, but I don't know the chemistry. That is very nice. One of my students in Southampton has been working on octocorals for her PhD, both in the Azores and in the Mid-Atlantic Ridge and in the Wittard Canyon in the Northeast Atlantic, Kirsty, and she would just love these corals. But I told her we look and don't touch on these cruises. Let's go and have a look.
So the fact that we have very few, well, we have no hydrothermal fauna here, is that correct? We just have sort of filter feeders that are normal in the deep sea?
Yeah, yeah. The what we're seeing are animals that you would find on, I guess, a normal rock surface. You know, one of the real problems we have is rock is no, until really the advent of the ROV, rock was one of the great ignored environments in the deep sea. Difficult to dredge. Um, you know, in the past, you know, people have brought up stuff. One of my colleagues, Bram Merton, brought up samples 15 years ago from dredging, froze them, and one of my other colleagues identified them. And you know, the amount of information is actually highly limited. Now we're using ROVs. We're realizing there's a much greater diversity than we thought. And the other problem is that it makes it very difficult for us to identify these from videos, is that virtually every animal's the species is determined from small spicules in the polyps. Now you can see the polyps, they're tiny little things sticking off the branches, so you can't see the spicules in them. But they're not identified from the shape, and this is proving very, very difficult for those people working on these animals from video in the deep sea. But what we do know is that the diversity is much higher than we originally thought. And I guess, once again, this is one of the great joys of actually having the ability to go and explore, so people can come back, we know they're there, and can come back and collect and identify and look at their biology. Sometimes it's been very difficult to me to explain that, you know, when I was a young deep sea biologist 35 years ago, that we just trawled everywhere. That was the only way you could get samples out of the deep sea. Essentially, the Americans had Alvin, and the French had a submersible called Sayana, the Soucoupe, and they were the only people that got a chance to get into the deep sea to have a look. And to being able to see the sort of areas that I would have liked to have gone and sampled, and they're much easier to sample it this way now.
Paul, this is Chris. Is the ship moving at the moment, please?
I think the ship is just moving slightly. They're just getting adjusted.
Understood. Thank you.
The ship is stopped. Yeah.
Should we be moving?
Yeah. I think, guys, we actually need to move on.
Yeah, a question I have is that, Chris, from your methane sampling, was there some little tiny signal up by the furthest north waypoint for today, or not?
No, the way it worked was we actually did our line from south to north to here. We did actually have above background methane in the southern half of the line, so probably from this point all the way back as far as we've come, I think we're about halfway along our planned line for the day. But what Sarah Bennett's been doing with processing the data is showing that in terms of density, there is a shallower plume here in terms of a thermal anomaly than at the Von Dam plume. But the methane that we saw that was actually in the very deepest waters hugging the bottom here was actually consistent with it could actually have been further dispersion of the Von Dam plume just bathing along the southern side. If you look in the high pack video now, the red sort of orange transition, it could actually have been plume water that stained from Von Dam getting all the way across here, giving rise to the methane anomalies.
Okie dokie.
So there is evidence for some warmer water, shallower, which could only really be coming
Chris.
from here.
Sorry, Nav.
So Bridges informed me that we have a drill in the next few minutes, so we're going to wait for all the excitement to lift down, and then we'll go back over. I don't know if this is white or what. Well, it might be white down on the bottom of this thing.
Oh, I do find this seabed quite remarkable, seeing these things. The Dave Lavolo's comment this morning was, and I agree with him entirely, that why should they come down to the seabed here? This is an oligotrophic area, and it seems to have very, very little indeed to feed on. I don't know, it's even the shallowest bit round here. If they wanted to come down and clean their teeth. Actually, can you up the zoom just, no, or lift it up just a little bit? No, sorry. Sorry, guys. Okay. Okay, now if you can just track up to the top of the screen and keep going up. There was a xenophyre. Just there. Oh, just gone past it. That looked very much like a xenophyre as that little slope as we went up there. That's the thing that Dave Billett was really interested in. Thanks. No problem, Dave. Okay, here we are. Guess what? Over sediment. Various mounds. These little pinnacle mounds here are most likely formed by some form of worm, maybe what's called an echiuran worm. Certainly in the North Atlantic we find these little mounds scattered all over the abyssal plain, and invariably they contain one of these peculiar little worms inside. More of these gouges on the seabed. I think that could be a research topic in itself. You're looking at the curved piece or the piece in the groove?
We're looking at a piece in the groove. We thought it, our mind made it out to be a lobster or something totally inappropriate for where we are, but we popped down for a look, and this looks like a round piece of coral here.
Yeah. It certainly would.
I'm afraid that might mean more excitement than fun. Have you seen that footage of Jason in the eruption? They were getting a nice close look at some pillow lavas and some tubes and stuff, and all of a sudden, something started to happen. Basically, we're able to back up just slightly faster than the eruption was coming out.
It's a very impressive bit of video that Jason nearly became part of the hydrothermal vent, or part of the seafloor, should I say. Still moving off in a direction now of about heading of 11, more or less going north. Looks like something slipped away there, maybe rolled downhill. Not a huge evidence of, oh yeah, and that looks like some of the rubble that's gone downhill. That's looking down the slope more or less to the east-northeast, I suspect. Ho, 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 ho. Am I glad I'm in the chair.
And is Chris the victim because we haven't found any vents today?
Yeah, I think he might be going off in a bit of a huff. But it's one of the hottest things we do on the ship because we have to go outside to go to the boat stations. We have to take life jackets and put them on. We have to carry our Gumby suits with us. We have to have long trousers on. Have to have a hat on. We're supposed to take a jumper with us and things like that. And essentially you stand on deck in full sunlight and it's hot. Nice big hole.
Why do you need Gumby suits down there in the equatorial water?
You can lose heat in water, even if you got into the water at 25 Celsius or even 30 Celsius, you would lose heat slowly over a long period of time. But they also act as flotation as well.
So you guys can practically swim to Grand Cayman Island in a day.
You might be able to. I couldn't. I couldn't swim it. I'm hoping they might send a helicopter out for me. Every person had to put the Gumby suit on to make sure they could get in it. It's one thing I find really difficult to get on. It always just clings in all the wrong places. Maybe I'm just the wrong shape.
Yeah, I've done it in the southern Indian Ocean, and I've carried them around in the Mid-Atlantic Ridge, but I haven't actually had to put them on the Mid-Atlantic Ridge.
No, we all had to put them on. Oh, here we have a Bathytrois. For those of you not familiar with this is a tripod fish, and I suspect if it's like any other tripod fish I've ever videoed, it won't do a great deal. It'll sit there. It is a very dark tripod fish, isn't it? Yeah. Wow. Oh, he's actually doing something. Or is that the turbulence caused by the sub? Yeah. Oh. Oh. Hey, just checking out what's come to see here. I think he's checking us out to make sure we're edible.
Are the lasers on?
I've asked for the lasers on, please. Oh, wow. He is tiny. Yeah. Yeah. That's quite amazing. No, looking at the video, I thought it was bigger than that, but that is really impressive. Yeah. He's most likely wondering what these two monstrous vehicles are doing, looking at him.
So can we keep moving towards the waypoint? Because we need to see those rocks before we come up.
Yeah, got that, Bobby. We're on our way there. We're going to make it. Now, if we are going to make it, aren't we? Because we want to spend time looking at rocks at the last waypoint.
Does as well.
Just for information, for those of you out in the ether there, listening to this and watching this through the internet, this is the Okeanos Explorer working in the Cayman Islands Exclusive Economic Zone. We are using a combination of the ROV Little Hercules and the system Sirius to look at the seabed over Mount Dent at approximately 2,200 meters in the central part of the Mid-Cayman Rise. I'm Paul Tyler. I'm the watch leader at the moment. We have another half an hour or so on station here, and we're just coming up to our last waypoint of the day. Those of you watching, we just passed Holothurian, and we've been going over a lot of sediment, and we're hoping very shortly that we might start coming into some rock.
We only have the backscatter from the multi-beam pulse and nothing like the auto-sub data.
Okay, just for the multi-beam at the moment. Welcome back, Chris. I understand you've been put in a boat that was cast adrift. Is that right?
Now, the great thing about ocean exploration is that we have an expedition coordinator, so I get to delegate all that to Kelly. She was a lovely girl.
So she went to Dunkin' Donuts?
I'm sorry, Nav, I missed that. Okay, the backscatter's up on the screen. Yeah. I'm not, that doesn't tell me a great deal, folks. I don't know if it tells you anything. What a beautiful brittle star. Good grief. That's the first brittle star we've seen for about 5 days. Now, those of you that aren't sure what I mean when I'm talking about brittle stars, these are related to, believe it or not, these are related to the Hodothurians that we've been seeing, and are related to starfish, they're related to crinoids, and they're related to sea urchins. I have to put in a particular bias here. I particularly like this this class of echinoderms. I did my PhD on them best part of 36 years ago, and this is a really nice specimen. This is an Ophiolipidae, and it's most like the genus Ophiura, and you can tell that by the patterning on the disc. Those of you that are biologists will recognize the radial shields and the primary plates on the disc, but also if you look along the arms you can see the very short spines, and that's the sort of patterns that give away this as potentially being an Ophiura. That's a really nice specimen, nice salmon pink colour, that's very typical of Ophiura as well.
Bridge.
Yes, go ahead.
We find these throughout the world, both in shallow water and in the deep sea.
7 minutes.
And it's just nice to see one. So sorry about my little bit of excitement there. I've been hoping to see one in all the dives, and it's the first one we've come across. So, you know, that's my smile for the day. I think we need to move on, guys. This is Geology Dive.
Yeah, I shot out ahead. I copied ahead, picked this up for you just to keep us entertained. But we have not slowed in the slightest on our inexorable march toward the rocks that we know to be there.
Yeah. Yeah.
We have it on good authority that there will be rocks.
Now we're looking for rocks. We're getting there. Bobby assures us going to be rocks there. We're right on schedule at the moment to be there on just on the hour. The reason I got excited about the Ophiuroid or the brittle star that we saw just now was that essentially these are very, very common in the deep sea. If you trawl an abyssal plain, you'll come up with hundreds, if not thousands of them. And that's why this sort of depth, 2,000 meters, I was really quite surprised that we've seen so few, particularly as we've covered so much sediment. We've seen lots of Hodothurians, which I would expect, but I expected to see more Ophiuroids. But so that's just how it is. Right. Anything that looks really solid, let's go and look at it. Okay, Bobby and Mike, plan A is to steam on towards 10. There's nothing round here we can pick up on the sonar that looks as though it's rock-like. So we're going to steam on at 0.4, and we're heading at the moment it's 350, and we're just going to see if we can find anything solid. The first solid lump we're going to have a look at. You happy with that?
That's great, thank you.
Sorry about this, but someone shifted the rocks.
It's a bad day, but that happens.
Oh, it's been an interesting day. Again, it's been a learning experience.
So look at the trail. Okay, now these are familiar to us, friends of us that were in, I think it was Hawaii. We saw these. At one end or the other will be a specimen if you want. So the collections of the Holocaust. Well, I think this is different. I think something vacuumed up a wide swath and deposited undigested gravel
Ah, now this is quite remarkable. You get these patterns on the seafloor that appear to be, created by an animal. You can imagine how an animal been ploughing through the sediment, and we followed these in the Bahamas for meters and meters, really getting excited about finding the animal, and it's not there. Ah, what's that? That's a squat lobster. Have you ever read the book Dune? And it's about this worm that goes through the sediment. Yeah, that goes through the, and I keep thinking, there must be a deep sea dune because you get these patterns where they sort of go through and leave this pattern on the sediment, but you never find anything in the trail at either end. And you know, oh yeah, that's true. Hmm. Of course, guys, this could be actually a function of the holothurian, some holothurian that goes for a little swim, then lands again, and then ends up ploughing through the sediment. And but it's really interesting. You're following the trail. Quite. You must find it's one. Yeah. It'd be one of these little kiddies dump trucks that's been chucked over the side of the ship and just whirred its way along till it's finally run out of battery. Oh, don't sit. Another groove.
Paul, are the little black specks rocks?
I'm sorry, Bobby.
Are the little black specks in the groove? No, they're not rocks.
No,
They're
they're
holes.
holes.
Is that correct?
Yeah, they're holes.
Anybody living in there?
There could be, but we had a look earlier on at those sort of things, and it's very difficult to see what was in the holes. So we're just going on, still looking.
Okie dokie.
No, yeah, I
Harvey,
don't know.
knife, Rich.
No problem at all. Dave, basically, we didn't find any more rock, so we went through today's waypoint 9 towards waypoint 10. I think we almost made it to today's waypoint 10, but it's all soft sediment around here. So, yeah. So no, we're done with science for today. Thanks. Okay, folks. Just to let you know, that's the end of the science program for today. Um, Dave Olivello is now going to take over. There's going to be some additional work with the ROV, actually orchestrated by the ship. Um,
cones and tell us where to go. But don't tell us where to go until you found the conical mound. Bye.
RV nav bridge. What time are you aiming for pulling? Okay, thanks.